Hey guys, welcome back to the shop. My name is Gary and Happy New Year's. You know, I get a lot of questions on my YouTube channel, and over the last 3 months since we've had the plasma table, the number one question I've got is about this CNC plasma table, and do you like it? You know, how's it been working so far? Things like that. So I thought I'd make a video and do a review on the table, and I've had great luck with it so far. There have been a few problems here and there, but the company's been great to work with. The support is awesome. I've never had one issue in terms of getting the answers I need, or whether it's just something I've done wrong or whether it's an actual issue with the machine. The support has been great. Probably the number one question I get is, how much is it? How much did it cost? Well, if you go check out the website truecutcnc.com, you'll see there, various options listed there, a number of different options. So really the pricing really varies on what you decide to get. I think the most common, tables out there are a 4x4, which can take a 1/2 inch sheet of, steel or plate, and a 4x8, which will take a full sheet of 4x8 steel or plate. Yes, there are 5x10 sheets out there that you can get, and larger, configurations and so forth, but most people have in their area 4x8 sheets, and so I opted to go with a 4x8 table, and it is a little bit larger. I think they give you maybe 6 inches on the width and length, so you can easily fit a 4x8 sheet on there and have room, around the edges and so forth to position them. The other question you want to ask yourself is, do you want to just buy the gantry kit with the software bundle and everything with it, or and build your own table, or do you want to buy the whole thing turnkey? So I ended up just getting the whole thing turnkey from them, because they do offer a kit where you can get the gantry from them with everything fully assembled and the software bundle and all that, and save $3,000, and they give you the blueprints, CAD drawings to build the table. So if you want to build your own table and buy the gantry kit, you can do that. And I started kind of looking at all of it and looking at what all would be involved in building the table. I mean, it's not overly complicated, but it is. I mean, there is a fair bit of work going into building the table, the water tray, and and all that. And then the cost, you're probably looking at the materials alone to build the table, you're looking at probably close to $800 or $1,000. And then you got to have it powder coated, and find somewhere to get it powder coated for under $1,000. I don't think you can. So all of a sudden there, you're at $2,000 just in the cost of getting it powder coated in the materials. So that leaves you kind of $1,000 in labor that they're charging you to put it together. And if you think about the electricity to do all the welding and the labor involved in doing the welding, $1,000. I mean, that's what it came down to, is $1,000 pay them to actually build the table. In my mind, it was worth it, and then there was going to be no issues of did I build it to spec? Does the gantry fit and work properly on it? Because if they do it in their shop, they're going to test it all out. Which they did do before they shipped it out. So again, there's just a lot of variables and options available in terms of getting one of these, and the prices vary, accordingly. But I'm just going to share with you what I paid for the configuration that I got. So 4x8 table, fully assembled, steel gantry with the chain drive movement, and the other option there is rack and pinion. Fully assembled was $10,000. Now they're located in Jackson, Tennessee, and so from Jackson, Tennessee to Dallas, Texas, basically, they shipped it on Hot Shot, and that was $800. So you're looking at $11,000 just to get the table here. And, so that does not include the plasma cutter itself. And so, they kind of prefer Hypertherm, although they'll work with Thermal Dynamics and I think the Lincoln plasma cutters as well. But so the Hypertherm 45 is Powermatic 45 is, I believe, around 2,000. The 65 is like 2,800, 3,000 range, and I ended up getting the 85, which is rated to cut 1-inch steel plate, but in reality their ratings don't really give you a really clean cut at those thicknesses. It will cut 1-inch plate, but you don't get that great of a cut. So the Powermatic 85 is I believe it was about $3,600 is what I paid for it. So $10,000 for the table, $800 for shipping, and $3,800 for the plasma cutter itself. The other thing people commonly ask about is the software and the computer. This PC came with the unit. It's a Dell Inspiron. I don't know about the specs on it. It is a Windows 10 machine, and it comes preloaded with the software that they give you, or they purchase and bundle in with it. So it is included in that $10,000 price for the table. And it does come pre-configured and the software loaded on it. So you really have three main software components. You have the CAD software, which is where you do your drawings and so forth, and they include BobCAD, a license for BobCAD with this, which I to date have not used yet. They also, for the CAM software, which is where you take the drawing or the CAD software and get it converted over into G-code so that the machine can actually cut it, and they give you Sheetcam for that, which to me seems like a good product. I've gotten pretty familiar with it, and it's pretty stable, works well, so happy with that. And then the last thing is the software, the controller that actually runs the gantry and runs the motors, and that is called Mach 3, and that is included also. So you have your CAD, your CAM, and then your actual controller, and it is a three-step process. Everything you want to cut really goes through those three steps. The CAD, looking at the drawing itself, whether it's something you're creating from scratch or another drawing someone sent you. The CAM, which is converting the drawing into something that the machine can cut. And then the controller itself, how fast is it going to run, what's the pierce height, all those kind of settings, is Mach 3. So with everything all in, you're really looking at about $15,000 when you include the table, the plasma cutter itself, and getting it shipped and all that. Pretty close to $15,000. Now that does not factor in your air system, your electrical system, and your water system for how you want to manage that. So you need to plan on having the electrical ran for your plasma cutter, and we have three-phase electrical here in the shop, so we're running the plasma cutter off of three-phase, and it's running off of a number 6 pulled line. So to get the breaker and the lines and all that, I mean, it's probably another $500 to get electrical pulled, and I did that myself. That was just for the materials to do it with. And then you're also looking at your air lines. You need a really good air supply. Again, depending on if you're just going to run a Hypertherm 45, you can get away with a lot less electrical and a lot less air. If you want to run a bigger machine and be able to cut thicker plate, then obviously it steps up in price. The last thing is the water table. They give you a drain outlet for it, but you have to purchase the valve and then figure out, do you want to plumb this permanently with water so you can turn it on and off and fill your table up, or do you just want to drag a hose in to fill your table and drain it when you get ready to clean it? So those are extra kind of expenses that you need to think about. So again, the airlines and air supply, how big's your compressor? Is it going to be enough to run the plasma cutter? The different Powermatic 45, Hypertherm 45, 65, 85, 105, 125, all those have different spec ratings, CFM ratings that you need to be able to make sure your compressor can run it. And you need clean, dry air. You need lots of filtration. If you don't have an air dryer system, it's probably best to get one. You probably can get away with desiccant filters and all that. You just need to run a lot of them and change it often. All right, so just after giving you an overview of the table itself and the cost and all that, I thought what we do in this video is just walk through the process of cutting something on the table using the software that came with the machine, plus one other piece of software. So the thing that most people have or want to do, or a lot of people want to do, is have people send them logos, have people send them pick out artwork or some sayings, lettering, things like that they want to have cut, made into a sign. And most people don't have vector files. Their images that they have are bitmaps, and the machine and the CAD software doesn't know how to cut a bitmap. So you have to get that converted over into a vector file that can then be converted over into G-code. So I thought I'd just show you, an example of making a YouTube logo. If you wanted to cut your own YouTube logo, this is kind of how you do it. And this would go for anything really that you wanted to cut. So if you just do a Google search, you see here I just search for YouTube logo, and if you go over to Google Images, you know, there's a lot of different things that you can do here, but one of the, you know, common things in Google Images is to go to Tools and pick out something that has a transparent background. All right, so if you do that, that'll further refine your search and give you something with a transparent background. So I'm going to pick out this one here. You can see that this is just a basic logo, but again, it's a PNG file, which is a bitmap image. So the first thing I'm going to do is bring that into Inkscape. Inkscape does not come with the machine, but it is a free download. There's lots of support out there for it, lots of YouTube videos on it, and so far I've had pretty good luck with it, and it works really the best for things like images and getting them converted over, where Fusion 360, which I hope to be able to use primarily, isn't really good for that kind of thing. I do use Fusion 360 when I design new things or come up with new things that are from scratch, but to take an existing image and get it ready for cutting on the machine, it's not really that great for it. So you can see we've got it pulled over into this. So the first thing you will do is actually select the image once you're in the tool, and then go up to Path and then select Trace Bitmap. And you can see it automatically starts to pull in the bitmap logo. And if you look at these, you know, these options here, you can change these up or down, and that will, you know, further refine how much detail is coming over. And so if you just click the update, you know, you can change these numbers more dramatically, and, you know, further refine that. So I'm just going to click OK, and we'll close out this window. And you'll see if I move this over, I now have two images. This new one that I've dragged over is the new vector image, and then this one is the old image. So I'm just going to click on the old one and hit the delete button and get rid of it. And now I just have the new one in. So now I've got my vector image over, and then I'm going to go up here to View and change the mode of this, the display mode, to outline mode. Now you're starting to look at something that the machine can actually cut, but you're not quite ready for that yet. There's a few things that you need to do. So if you click on this edit nodes button here, you start to see you know, all of these points on the screen, and these are the different intersecting nodes where the you know, how things are drawn out. And a lot of times you'll come and, you know, grab an edge like that. If you see how it all stayed together, then you're in pretty good shape. So you can just go and undo that change. But a lot of times, this is not a good example of it, but I'll break one here and show you that. So now if I show you this, you can see it doesn't stay together. It's disconnected. And sometimes when you get artwork over, you'll have a lot of these things that look like they're together, but they're really not. So you have to kind of go and find all those and fix them. And it's pretty simple to be able to do it. You just, you know, wherever they're overlapping at and they appear to be, you know, solid together, you just drag across and highlight those two nodes and go up here and click this Join Selected Nodes, and you'll see it'll put them together as one. And now when I drag this, you can see they're together and selected. The other thing that you need to do here is you can see the center of this is think about what's going to drop out. So you can see the center of this B. If, you know, when we cut this on the table, the center is going to cut first and drop out, and then it's going to cut the outside of the B and drop out. Let me zoom in a little bit more where we can see this. So you can see this O would drop out, and we would just have the outline. We wouldn't have the center, and the same thing on the center of the E. So you need to be able to go and make changes to that so that those don't drop out. And rather than go through the details of that, I've actually already previously done this, and I'll go down and just open up a file here and show you that, and actually how I did it. All right, I just had rearranged this, you know, on the screen so that it would cut better. But if you, I'm going to go change to the edit nodes here. If you see this, you can see what I did is I broke the lines here and here, and then added in 2 more lines to create for the B and for the E. So now when it cuts this, it's going to cut it on the outside and leave the inner part connected so that it doesn't drop out, and we still have that in our final selection. So that's pretty much it for CAD. That was pretty straightforward on this because we traced an existing image. A lot of times if somebody sends you an image, you'll have a lot of overlapping lines and things that, you know, you can see there's a little squiggly right there, you know, that don't quite line up properly, and you need to go clean those up. So next we're going to go take a look at the CAM software and Sheetcam. All right, so the next thing we're going to take a look at is Sheetcam, and we'll go ahead and launch that now from the desktop here. So again, CAM is our software that we use to take an image or a CAD drawing and convert it over into G-code so that the machine can cut it. So from here, we just want to go and import a drawing, and I am going to pick this one, which is the one we just worked on. So I'll open that up, and you get this dialog box. Depending on what format it's in, I saved that as an SVG file, but if it's a DXF file, you'll get more options here. But the thing is, we can scale it right from this, and so, you know, that was a 10-inch wide drawing, and if we wanted to say make that 5 inches wide, we would just go here and say 0.5, and so that would give us a 1 to 1.5 scaling. But we'll just leave it as it was and cut it as a 10-inch wide one. So once I click that, you'll see it comes and imports it. If you have overlapping lines or some of those disconnected nodes that I mentioned earlier, a lot of times when you do the import, the CAM program will come up and give you an error message and tell you that it's removed duplicates, or there's overlapping lines, you know, things like that. So in the CAM software, the first thing that we're going to do is come and set a few variables. And on this, I'm going to turn the torch height control off because it's going to be such a short cut area that, in its thick material, that's not going to be moving around while the cut's happening. So we'll just turn that off by setting THC equals 0. And there's a little bug in this where it, for some reason, sets it to 15, so you have to kind of open it and reset it to 0 again. This is going to be our cut order over here. Before we do that, though, I wanted to show you this. If you want to, let's see. If you see how this is laid out, this is our 4x8 sheet, and this is showing you the placement of where those are on your sheet. And if you want to move those around, you know, you can just grab this and move it anywhere. So if you have a sheet on the table and you've already cut a bunch of stuff out down in this section and you want to move it up here, well, you can move it up there to cut it. And when we get ready to go into Mach 3, I'll show you, you know, how you set the machine to know to go up here and make the cut versus down here. All right. So so we'll set up our we'll zoom back in on this. We can see what we're doing here. So we've set that variable. The next variable that we're going to set is we are going to change the feed rate, and we're going to run this at 50% of what the machine. Again, sometimes you have to go back in and change that. So just double check and look at what's happening. So make sure this is on. Okay. So you see we have the feed rate set at 50%. Now we're ready to set our first tool path. So we're going to set an inside offset. Well, let me take that back. First thing we're going to do is there's only one thing in this whole area that that has to cut out first, and that's the inside of. Actually, there's two things. So we have an inside cut here, and then all of this tube lettering is going to be cut on the inside. So so we want to actually move that. So we're going to go to Edit Contours, and we're going to move this to a new layer. And I'm just going to call this Inside Cuts. And then we want to move all this over to the Inside Cuts layer. So I'm just individually selecting each one. Alright, and you see up here we've got the two layers, and if I turn that off, it'll show you what's on the inside, and then the white, which is kind of how it defaults, shows you what's on the outside. So I'm going to set a toolpath here, and we're going to pick Inside Offset, and you can see when we pick that, it shows you it's going to cut on the inside of the line. And if we were to change it to Outside Offset, it's going to cut on the outside of the line. So we want to cut this on the inside of the line. So we're going to go Outside Offset, and we're going to pick our Inside Cuts layer. And now we have to set the kerf width. So to do that, let me cancel back out of this. I have a folder that I've set up on the desktop where I've got all the different kerf widths and variables that you set the machine with. So I'm going to go here to kerf widths, and we're going to be cutting this out of 3/8 inch aluminum. So if you look at aluminum down here, and you go and look at your various thicknesses, and you come down, and we're going to be running 85 amp shielded, you can see we need a kerf width of 80 thousandths. Alright, so I'm going to go back over to Sheetcam and go back into this, select our Inside Cuts, and we want to pick a tool that has an 80 thousandths kerf width. And then some of this other stuff, I'm not going to go into detail on it, but there's just various things that you need to set here on, how it's going to set, an overcut or a lead in and a lead out. And I'm just going to leave these as default for now, and not get into that in the interest of just showing you how to get through this, pretty quickly. So now all of a sudden you can see we have a cut path here on the letters, and these little hook in and hook out is the lead in and lead out on how it's going to cut it. So we're going to cut the O, and then we're going to cut all this out, the tube. And again, these are going to be positive letters here, and then the tube are going to be negative letters, and so the inside of these are going to drop out, and then the outside of this, and we're going to actually use the letters themselves. So that's a decision you have to kind of make on that. And remember, we talked about changing the inside of the E and the inside of the B so that it doesn't drop out. We added those little cut ins there, so we got that set. So now we're going to cut that out, and now we're going to set one to cut the outside. So we're going to go Outside Offset, and then white, which is our default layer for the outside. We're going to leave the same thing on that, and we're going to select OK there. The one thing we didn't do is go set a variable and change our feed rate back up to 100%. The reason we slow our feed rate down on the inside cuts is because the inside cuts are usually, really tight radius, really intricate, and so the machine needs to run at a little slower rate because you don't want to have it overrun. It'll just make a nicer cut if you run it slower on the inside cut. So we want to go set our feed rate back up to 100, and again, we've got our outside cut. So now we've got all of our cut paths set up here, and I'm going to turn the arrows on. So now you can see what this thing is going to go. It's going to cut in the direction that the arrows are happening. And let me pick one out that you can see here. You can see let me turn the arrows back off. You can see this is going to come here and lead in and start cutting, and it'll cut all the way around this until it gets back, and then it'll lead back out right there. So that's that lead in and lead out. And that's really it. This is pretty simple setup. Now if you wanted to cut more than one of these on the sheet, you're going to go back up to your nesting, and we're going to say duplicate that. And now we've got a duplicate. Now we could just cut two out. If you want to create multiple, you can select multiple duplicates and just keep making as many as you want. Okay, so we're now set up in our cam. We got to convert this over to G-code so that our machine can run it. So we're just going to run the post processor on this, and this is the process that takes the image and converts it over into G-code. So I'm just going to do YouTube sample, and we'll save that. And you'll see over on the right side of our pane here, we've got all of our G-code, and this is the code that, you know, is telling the X and Y axis of the table, the gantry, the motors, where to go. And you can see that, you know, X3, these are just positions, and that's it. It's as simple as that. These commands just drive the motors, tell them where to go. So after that, we go over to the Mach 3 software, which is the software that actually runs the table, tells the, you know, takes the G code, and go into the Mach 3 screen here, and this is our controller screen for the actual table. So we'll come up here and say load G code, and we'll go down and find our YouTube logo that we just made, and I'm just going to pick one that I've previously done here, and so you can see over on the right, it's going to show you what the torch is going to do, how it's going to move around, and, you know, the position that it's going to do. And in the center of the screen, this is kind of your real-time monitor, the position of where the torch is at any given time. And then over on the left, this is the actual G-code as it's running and processing. So we have to set a few variables here before we can run it on the machine. I'm going to go back out to my folder and look at the cut speeds for 85 amps on aluminum, and I'm going to go down here, and we're going to run 3/8 inch aluminum, and you can see that we need an initial pierce height of 150 thousandths, and we need a torch height of 60 thousandths. So we're going to pierce it at 0.15, 150 thousandths, and then once it pierces and starts to cut, we're going to be cutting at 60 thousandths. And then our speed, it's telling us, this PDF software can't quite make it out there, but you see 380 thousandths here. Oh, and we need to set a pierce delay, how long the pierce needs to take as it's piercing through the material, of a half a second, and then our cut speed of 80. So 80 inches per minute to get the best quality results. And again, that's on 3/8 inch, and we're looking at aluminum here, you can see at the top. All right, so we'll flip back over to our Mach 3 screen, and we'll set some of those up. So we need a pierce delay again of 0.5, so we'll set that. We need a pierce height of 0.15, and we need a pierce cut of 60 thousandths, which is pretty much the same. Your cut height is the same on everything. And then over here we're going to set the speed, and it said 80 thousandths. This is kind of a small part, and it's, you know, the inside cuts and all that. I'm going to run that a little slower than the recommended. I'm going to run it at 60 inches per minute. All right, so those are the variables that we need to set, and from there we're going to just hit cycle start, and that'll send the machine off to start to cut, and that's all there is to it. So we'll flip around and get some aluminum on the table, get the torch into position, and we'll hit the cycle start and get it to cut. All right, so I'll put the 85 amp tip in the torch here, and I've got the plasma cutter itself set to 85 amps. So we're pretty much ready to cut. So the first thing we're going to do is position the torch head down in the right position here to get started. And I'm just using a little USB keypad because Mach 3 uses your keypad on the keyboard, you know, your number keypad, to control the XY movement and other, you know, shortcut keys to control things on the machine. And you can get one of these little Bluetooth keypads that you can use as well, so you can kind of get over into place and see what you're actually doing here. So I'm putting this down at the bottom corner So we should be able to be ready to get going and cut this out. So now that we got it positioned, we're going to zero out the X and Y so that it now thinks this is the new 0, and then hit cycle start. So we'll go over to the screen and do that. All right, well, I just took it over and did a little cleanup and hit it with a burnisher a little bit, and yeah, you can see it came out pretty nice. The you know, it's pretty thick aluminum. You can see the edge of it there. You know, it's a little on the jagged side, and then that's the back side of it. By the time it pierces through and blows through the back, it really, you know, can leave some messes on the back with aluminum. Steel does a lot nicer, but all in all, not too bad, really. So yeah, hopefully I didn't bore you guys to death too much, and you got something out of that. If you already know CNC stuff, and if you already got plasma tables and mills and whatever, then this probably bored you to death. But there's a lot of guys watching the channel that are thinking about this and have asked a lot of questions, so I just thought I'd take the time to walk through the entire process. So, all right guys, thanks, appreciate it, have a good one.